Hello, everyone. Thank you for coming. So let me just address two questions here very quickly. So one is about your quiz number 3. I'm going to publish the quiz number 3 result later tonight. So you definitely see it on the e-class. You can check it later this evening. For your lab number 1, we're still trying to grade it right now. So it's definitely we are busy grading it. So we're trying to get back to you hopefully by the end of this week. If not, we'll try to do very, very soon, hopefully sometime within the reading week. I'll keep you posted, okay, for lab 1. Okay. All right, so what I will do today, I think I got quite many questions there on the Google Doc. They're good questions, actually. So I'm not too sure if I can go over all of them today, but I will try to go over maybe 1 or 2 items in my agenda today to start with, especially the exercise that I ask you to do for your week number 4 lecture. That one there will be maybe useful for your quiz number 4. I'll go over those 2 items first, and then after that, I'll go over all the questions on the Google Doc, as many as I can. And then I may want to leave maybe about 5 minutes or 10 at the end, so you can ask me some question dynamically if you wish. But I can put your question on the chat. I'll try to go over them whenever I can pause. Okay, let's start. Okay, so I'm pretty sure I'm sharing my screen. That's good. Okay, so now the first one here. This is based on the emails I've been receiving from you. So I think that this might be a good thing to clarify, and if you are not too sure, okay? Let me pose a question to you. So this is directly relevant to your lab number 2, okay? But I think that is a very good exercise for you to think about, to really reason about, rather than just guessing, right? That's not a way to go. Let's now recall what you did for your lab number 2. Let's say for your lab number 2, you got your model query of type relation, and then we got a domain, and also we got a range over here, right? String and integer, let's say, for example. And now if I say across over here, across the model, so I'm crossing the relation. You can think about every math model classes, every model class is like a collection class in Ivor-based library. So they are iterable, that's for sure. If you check their source code, you will see that they implement the new cursor feature, and also the inherits from iterable. You can see that. So now, let's say if I got this particular cross loop here, and then I say across the model is X over here, right? And then let's say we're doing universal quantification, and then we are trying to use X in the body of the universal quantification here. So now, this is my question here. What is the type of X? What is the type? And then a hint for you. In order for you to figure out a type for X, right, you should really take a look at, well, number 1, okay. Let me give you a little bit hints, and then I'll pause a little bit to see if anybody got an answer. In order for this particular across to work over here, for this part here to work, the requirement is the relation must be iterable. So that is why in your lab number 2, you can also across the current database, right? Because database is also supposed to be iterable. So you can also say across the current database. So now we're just crossing the model over here. So this is allowed because relation itself is iterable. Given that, we know that given the model is iterable, so for sure the new cursor routine will be defined, right? Remember, the only deferred feature you inherit from the iterable, as we said in week 4's lecture, is the new cursor routine. And remember, the new cursor's routine is actually iteration cursor, right, of some type over here. And then for iteration cursor, what routines do we have over there? You got either item or after or fourth. So those are the features you can call. So now in this case, I would say you want to consider the item feature in order for you to figure out the answer. Okay, so now, guys, I just want to see if anybody knows what the answer should be. What's the type of X in the context of this particular loop? Okay, I can see, okay, thank you for responding. I can see, let me just, I wouldn't read your name, okay? So maybe somebody said tuple, either tuple or pair. I would say you want to be precise, either tuple or pair, they're different types, right? And somebody said it should be a G, and somebody said it should be pair of GH, and also G, and also pair, okay? And also tuple, right? Like different possibilities. Imagine that if this is a quiz question, I can definitely give you different choices, but there's only one answer that's correct, okay? Before I tell you the answer, which I'm more interested in showing you the derivation process, you should really know. Okay, let's see this. every time if the question is really related to the iterated pattern, you really have to consider the architecture we have. And since the iterated architecture involves generics, so I think it's a wonderful opportunity for us to practice generics. And that's why this particular exercise you were assigned to for week number 4, that one is also based on the iterator design pattern, which I will talk about next. But this one is more like a warm-up for you, okay? So now I want to show you the hierarchy over here, and then we'll talk about how we can figure out the answer, okay? First of all, we know that the iterable is a deferred class. You only got a single generic parameter declared, only G. And then the only routine we need will be new cursor. And then I'll just write it for short, iteration cursor of type G, right? And then on the other end, we also got iteration cursor itself that's also deferred. And then we got G over here. And then we got fourth, we got item, also we got also after. So let's focus on the item over here of type G, okay? So now, that's why I said you should really think about what model the new cursor, the item really returns. So we are really talking about this particular routine. What's its type in this particular instantiation, right? We'll get there, okay? So now one more thing to say over here. Whenever we talk about X over here, as we learned about using the iterated pattern as a client, we say that whenever you have this, it's as if the model, which is iterable, we're going to say model dot new cursor. So implicitly, IPA runtime is actually going to call the new cursor feature because it's guaranteed to be available for model that is iterable. And then we're going to say the new cursor and then the item. And the item somehow is going to change dynamically between iteration, right? The cursor position will actually move from left to the right, let's say, for example. And then X will simply be assigned to this particular expression. So that's why once you figure out what should be the type for this item over here, you will know what the type is for X. Right? Let's get it clear first. So now I want to go to, I want to show you how you can find this yourself as well. So you might find it handy for your lab number 2. So let me just drag it, let me just move this iPhone Studio over here, okay, over here. So this is your starter code for lab number 2. Let me show you how you can find it out. We know that we got a relation class over here, right? That's a relation, okay? First of all, you can see that our relation class has the G and also H, right? So that's why you see over here, we got G and also H over here, right? No surprise. And then notice one thing here. When we actually inherit from the set class, which means a relation is just a special case for set. It's like a set of pairs. So now we're saying that we're going to, let me just show you also the set class over here. If you go to the set and choose the set that belongs to the math models, if you go there, you can see for the set class, it has only one generic parameter, just the G, because every member in the set should be of a single type, right? Just G, a single value. But now notice that relation here, we are saying that relation is simply just a special case for set, where every member is of type pair. So now, for those of you who thought there should be a tuple, you're wrong, okay? There should be a pair. And then, so the set over here is simply G, and then you can see that whatever G it is going to be iterable of G. So the G over here is simply used over here as a G for iterable. So these are something that you should really look up yourself to really know how you can reason about it, okay? So let me go back to my iPad, and then I'll complete the picture for you, okay? So now let's think about how we can instantiate the relevant generic parameters. So that's how you can think about. Let me use maybe pink over here. First of all, we know that for this particular, this particular inheritance relation, we're saying that the relation is going to be a set of pair. So that's something I just showed to you on the iPhone Studio. A pair, and then it's going to be G and H. Okay, that's what we have. And then the set over here is going to be iterable of G, right? So that's also something we saw. So now we can think backwards. So now here we're saying that model is simply of type relation where it's going to be instantiated by string and integer. So that means over here, G here will be string, H here will be integer. So that means it's really a special case of set of pair of string and also integer, right? And then you can think about this whole thing over here, the G is really the whole pair over here, and the G over here, right? So then you can think about the G over here is really a pair of string and also integer, right? And then if you just go up, you can think about iterable of G. So that's also a pair of string and integer. And now notice one more thing, right? When you actually think about how the new cursor is really being used over here, so that one there, iteration cursor, the G, is really corresponding to this G over here. In this case, it's simple. But when we get to the exercise, you will see that's slightly different. Okay, so now finally, this is the answer you will get. It's simply just a pair of string and integer. So that's the final answer. So this, to really work out this particular answer over here, you really have to make sure you really understand the architecture that's being involved. You got iterable, also you got iteration cursor over here. And then the set itself only has one generic parameter, but for the relation, that one there has two. How are they connected to each other? So you can think about this declaration over here is really important. We're saying that a relation is really like a set, except that every member there should be a pair of G and H. So that's the core of the reasoning over here. All right, so now what's the final answer? The final answer over here is, what's the type of X? It should be just a pair of string and integer rather than tuple, right? So for those of you who might want to write the cross loop for your lab number 2, if you use, for example, the model in the post condition, so what should be the type for X over here? It should be a pair. So what can you call on the pair? You can go to the pair class and see what kind of queries you can write. So it shouldn't be just like a, for example, if you say X1 and also X2, these two will not compile because you're not calling the right features on the pair. So what can you call? You have to go to the pair class and then try to look up what queries you can call. Okay. Any question about the first example over here? Any questions? All right. Okay, you want to think about this example here. So this is based on the emails I have received so far. So hopefully that will help you for those of you who haven't thought about this. So this would be some good exercise to think about. All right, so now let's move on to this exercise over here, right? So that's what I gave to you for week 4's lecture here, right? So hopefully everybody got a chance to try it, okay? So if you got a chance to try it, you got some answer already. So let's compare the answer. But again, I'm more interested in the reasoning process about the example. So I'm gonna suggest the following, okay? So way to really work out is really doing substitution of the generic parameter. So you want to find out where you're really instantiating the generic parameter. So in order to get, to really follow this more systematically, so this would be the steps I would suggest you to follow, the hints. I'm going to make this particular hints slide available to you after today, so you will see that as well. So the hints over here, we're just going to follow exactly the step that's suggested. I'm going to present in that way as well. If you got a different way of figuring out, you can share that with me, maybe offline, and then I can see that I can share that with everybody else in the class. But let's just follow my way. But if you got any questions, you can definitely ask me at the end, okay? So we're gonna follow this particular order here. We're gonna go 1.1, 1.2, and then 2.1, etc. Right? That's what we will do. Okay, let's do one thing at a time. So let me just go with, let's say 1.1 to begin with. If I go with 1.1, so I'm assuming that everybody have seen this exercise already, so I don't need to introduce you how the architecture looks like, okay? So if I go to 1.1, you can see that what we're doing here is we are instantiating the database class over here by instantiating, for example, G here to be string, and also H here to be integer, right? Agree? So now for 1.1, we can see that we are instantiating this particular generic class. And now 1.2 tells about, you can now think about in your mind what's going to be the actual instantiation. So you can think about for G, it has been instantiated by string. And for H, it has been instantiated by integer. I'll just put S and I over here. Okay. Any question about 1.1 and 1.2? Okay, so hopefully that's so far is actually okay. So now let's look at 2.1 and 2.2. That'll be step number 2. Okay, so we already know that G here really is string in this particular example about the use case over here. and H is really integer, okay, like a value, okay? So now, if you look at this particular loop over here, so now you want to see how can we interpret this usage over here. Let's take a look at this cross loop over here. What does it do? What it does is it's trying to go over the DB. So DB is actually iterable, right? You can see the database over here. You can see this particular inheritance relation from the iterable over here. That's why I can go across directly over the database, okay? And then you're saying that across the DB is T. So now this is related to what we said in the previous slides. I asked you about what should be the type of the corresponding item. So a similar exercise over here that we're going to do, okay? So now let's say this. So I can think about every time when we are using the across loop, what we are really doing implicitly is like this. We're saying that we're going to say db dot new cursor is going to give us some iteration cursor back. And then this T over here, since we're using is, right, it's going to just get the item that's pointed by the cursor. Dot item over here should be the type of the item, right? Everybody follow? Okay. So now, so that means, so what's the type of T over here? That's a question. So you can see the type of T. Somehow T will be used to extend the tuples linked list over here. So that means the type of T should really correspond to every member type of this particular linked list, which will be a tuple of integer and string. And let me just highlight this particular one. That's really important over here. So you can see this is the type of T. Okay, guys, any questions so far? So that will be the type of T. And then we know that this one over here is really the type of T, really correspond to the item type in whatever the new cursor that we talk about. We'll get there, okay? So now, so that's about 2.1. That's the information you should really get. We're basically saying that we're going to retrieve one item at a time from the iterable DB. And then every item that we retrieve is going to be of type tuple of integer and string. So that will really already give us enough information to really work out the rest. Okay, so that's about 2.1 and 2.2. What about 2.3? 2.3 here is very simple, right? So now what should we put this guy here? Okay, you wouldn't really want to put, for example, tuple of, let's say over here, the tuple of integer and string. This is not the way to go, right? Because this particular class database is actually generic. So you shouldn't really just put something that's too specific. You want to put something that's relative to whatever string and integer are corresponding to. You can see the string is corresponding to G, and also integer is corresponding to H. So what you really meant to say is, rather than saying I and S, so I is really, in general, about H. And the string over here, it can be generalized to this particular generic parameter, which is G over here. So that's why, for this very first one here, you will see tuple H and G. That's 2.3. I will pause over here and see if anybody got some question here. So hopefully I'm not going too fast, because I assume every one of you has at least has seen what exercise is about. So that's why I can just go directly to solve it together with you. Okay. So now so far I've solved up to 2.3. Any question? One thing you should note is like this. You can see that even though you declare the database over here to be G and H, however, the tuple over here should be H and G. So what does that mean? That means in general, you should not assume that if this is G and H, and this will be just H, this will be just G and H as well. It might be reversed, it might be the same. It depends. In this case, what you really should look at is how exactly is the item, in this case T, is actually being used. In that case, we can work out that should be H and G. That's exactly why I suggested the order of working out this particular exercise here. Guys, any question here? I would say that's an important exercise. Okay, Eric got a question here. Let me read it carefully. You know what? Can you guys actually send? I'm pretty sure you can send public message, right? I just want to make sure. Yes, you can. Okay. So how did I get tuple this time? So Eric, if you look at this over here, so first of all, you can see T here is going to be extended into as a member of the tuples linked list, right? So you can see the tuples over here is a linked list, which means every member there is declared over here, which is a tuple, right? And then, so that means every time when you're trying to get something from the DB, the iterable DB, so whenever you call the new cursor.item, it's going to return back to you a tuple, right? So that's why over here, you can see the iterable over here, it should be a tuple. Remember when you went over the lecture for week number 4, the tip I gave to you in principle. How do you work out the type over here? Think about every time when you retrieve an item from the iterable object using the cross loop, what should be the type of that particular object? So that's exactly over here, right? So the T over here is really represent every item you're going to get from each iteration. And then the T over here is really returned by new cursor.item. Let me just show you one more slide that's really important, which hopefully you didn't ignore for your lecture. Let me just go there quickly to show you. Okay, so now if you go to your week number 4's lecture here, if you go to, let's say, 4B, sorry, not 4B, 4C. If you go there towards the end, the second part, when we talk about how I can use the iterator pattern as a client. So you can see this slide here will be very important, right? So now if you declare some objects to be iterable, so that means you can definitely just return a new cursor from that particular new iterable object, and then you can actually get every item by saying cursor.item. So that's a very important thing to note. Okay. So Eric, does that answer your question? Or which part are you getting stuck? Okay, maybe okay, you think so. Good. Okay, or you can get back to me if you got more questions. Okay, guys, I'm going to assume everybody seems to be okay, you know, up to 2.3, okay? I would say 2.3 is actually quite tricky to get right, but if you get it, hopefully you're okay, right? Okay, so now we are done with 2.3. So let's now go on to 2.4. Okay, 2.4 and 2.5 really is for us to figure out 2.6, okay? Let me just tell you this. So now we know that this part here is already fixed, right? Let's think about the inheritance hierarchy here. So now you can see the database class inherits from iterable. If you think about the iterable class over here, it's always with the G over here, right? So that means what we're really doing is the G over here is instantiated by this particular tuple. So it's going to be a tuple of H and G. And remember, when we talk about how you can make use of some generic class, once you instantiate this G to be something over here, conceptually, every occurrence of that G should be replaced by that particular instantiation. So this would be tuple of H and G. So now this is why, in order to figure out the new cursor type over here, you can see the new cursor. Let me just show you more correspondence over here. The new cursor over here, inherits from the new cursor over here. So once you figure out this should be of type tuple of HG, so we know that this part here should also be iteration cursor of tuple HG. So it should be the same. Right, so 2.4, 2.5, and 2.6 is helping you the sequence to figure out what should be the type over here. So you can see this, tuple of HG. So it will just be consistent with this particular one that we how we instantiate a G for iterable. All right. Okay, so that's about 2.6. Any questions? We're about halfway for this exercise here. Any questions? Okay, so now that's about part number 2. Let's move on to part number 3. So part number 3, you can see. Let's talk a little bit more about how we execute, how we implement the new cursor routine. So you can see what we do is, so new cursor here, and then we say iteration cursor. And what we do is we simply declare some local variable over here. It's called, let's call that DB cursor. And then this can be any type that's actually a subclass, right, of iteration cursor. If you think about it, you can see that we got over here iteration cursor, and then that one there has a inheritance relation, and we got item iteration cursor. So that's why we refer to item iteration cursor over here. So that's okay, right? So now 3.1 is just to do a little bit of instantiation ourselves to make sure we understand what we're talking about. One tricky thing over here, let me point out to you. You can see when we are in this particular class where we got G and H, right? That's okay because G and H, they are not any existing class. So we don't have any name clashes. On the other hand, for another independent class here, we simply got N and N. Assuming that M and N, they are also not existing classes. So in some cases, you might see we simply put G and H over here, but it's not the case in general. In general, you can put any name you like as a parameter name. So that's why I want you to really make sure you really understand exactly how generics works. Because that's why I deliberately give you different names over here. So now in this case, I simply give you N and N. Okay. So now let's think about this. When you actually declare the item iteration cursor in 2.6, okay, 2.6 I'm talking about. When we are in 2.6, when you say iteration cursor, oh, sorry about that, not here. What I meant to say is 3.1 over here. If you look at 3.1, we are referring to item iteration cursor over here, and then we simply put H and G, right? So that means we have to make sure we understand, we have to instantiate the M over here will be instantiated by H. The N over here will be instantiated by G. So we got H and G, right? Just instantiation, okay? So now, once we have done 3.2, so now we can move on to part number, let's go to 3.3, okay? So now if you got item iteration cursor over here, so now if you want to think about the 3.3 and also 3.4, that's something you want to think about, right? The best way to think about it is, you can see over here, when you talk about a new cursor here, previously, we already worked out this should be tuple of H and G, right? So that means the G over here has been instantiated over here by just the tuple of H and G. Consequently, every instantiation for G will also be replaced by the tuple of H and G, right? Conceptually, right? But now we want to make sure when we try to figure out this particular 3.5.1, okay? So now we are done with 3.3 and 3.4 already. So let's now figure out exactly what 3.5.1 should be, right? So now we know that it's going to be tuple of H and G. So now conceptually, you might think about tuple of H and G. Let me ask you this, guys. If I simply write this as the answer, would that be correct? No, OFAC said no. I'm glad. Anybody else? You can disagree with me and OFAC if you wish.
Professor, you mean that if you write tuple HG,
exactly. So yeah, so Prathit, yeah, exactly. Let me just repeat my question here, just make sure everybody's okay. Guys, my question is very simple. We know that conceptually, we know up to here, tuple HG and also tuple HG. So would it be okay if I simply put tuple HG over here? Would that be okay or not?
No, Professor, I think that it should be something in form of M and N, maybe.
Yeah, exactly. So now, yeah, so Prathit, you're actually exactly right. So this will not compile simply because if you try to use the H and G over here, you're assuming that H and G should be declared as the generic parameter over here, but it's not the case. There's no H and G. So that means we should really use the corresponding instantiation for M and N, right? That's what we should use. So now we know that it should conceptually should be H and G. So now it should be M and N for the correspondence. So now rather than H, it should be N. Rather than G, it should be N. Okay, so now that's why when I reveal this particular guy here, you will see M and N, right? Tuple of M and N. So now that's about 3.5.1. Okay.
Or Professor, can it be NM or no?
Oh, good question here. So your question was, let me put it here. So you're saying for this particular part, so let's say that what the correct answer is. Correct answer should be iteration cursor, and then you put tuple and then MMM, right? That's the correct answer. You're asking me, can I say something like this instead? Iteration cursor, and then I put n, comma, n. Is that what you're asking?
No, I mean, can we put tuple n comma m?
That is exactly what I did. So here, yeah, there's a comma here.
No, Professor. I mean, in the tuple part, I mean n comma m. I reverse order.
Oh, you mean here?
N, m and n.
You mean that's what you meant?
I mentioned in the chat. In the chat.
In the chat, if you say tuple of, no,
like this.
no, that's not right. That's not right. So you were asking, okay, let me just handle your question first, and then I can give another question to everybody. So your question was, so this is the correct answer, right? M and N. If you simply put, for example, tuple over here, you just swap the order. If you say N and N, is this correct? That's what you're asking, right? The answer is no. Because if you put N followed by M over here, remember N corresponds to G and N corresponds to H. So when you say tuple of N and N, you're basically saying tuple G and H. And now if you think about G and H, they are not compatible with H and G over here. So you're creating some compilation error. So when you instantiate your generic parameter, the order matters. Does it make sense to you?
Yes, Professor. Thank
Okay,
you.
good. So, guys, I think this exercise is not that easy. So that's why I want to really walk with you all the steps, and also it's recorded. So maybe after today, if you still don't feel comfortable about this exercise, either rewatch the recording or maybe ask me again, either tomorrow. I don't mind going over with you once more. That's okay. Or but at least you want to think about it before you can ask me deeper questions. Okay. All right. So now let me just emphasize that this is not okay. Okay. Another question for you guys. The correct answer should be tuple and then MMN, right? What about another alternative answer? So this is number one, and that doesn't compile, right? How about number two? If I simply say, rather than just tuple MMN, what about I simply say iteration cursor over here? I'm talking about this prefix part over here. I'll simply put N and N. The order is right, M followed by N. The order is okay. But now, is number two okay? That's my original question. I see one comment from Nora. She doesn't think this will compile, right? It is not a tuple, right? To make it more precise over here, you can see that for iteration cursor, we know that what it is expecting will be a single value over here. But if you put M and N, there are multiple values. That's why we got to wrap it within a tuple. Okay, so that's why it doesn't compile. That's just a common mistake. Okay, I'll just put a cross over here. Okay, we're almost done. And then once we have done this, let's do one more, okay? So once we figure out this iteration cursor over here should be tuple of N and N. So we know very well. Once we figure out exactly what this should be, the item here will just be the same, right? Just the same G. So that means over here, the item here will just follow exactly what this one is. So that will just be tuple N, N. Again, if you simply put maybe tuple of maybe H and G, that wouldn't make sense because H and G are not in the scope for this particular class. Okay, so this one here is actually okay. It's going to be N and N. Okay, finally, that should be quite easy for you. Let's see this. Let's say this. We have the constructor over here, and then the constructor will simply take an array of N, an array of M. Okay, and we want to use this guy here, 4.1, to figure out the answer for 4.2. And 4.2, you can think about this part over here is a supplier, where we declare the routine. And this part over here, you can think about this line over here is where we use it. So this is the client part. So now what should this be, right? So we know that it should be somehow you put some array of N, and also, let me just say this. You can see this N, this is N, right? you want to put some array of n and some array of n, right? N followed by n. So that's the order we're expecting informally, right? This should be what's happening in our mind. However, you don't see this any type of any array of type n. There's no any array of type n in this particular class. We only got G and H. So what should we do? You should really find out the correspondence between n and also G and H, right? As we said before, over here, you can see n correspond to H, n correspond to H, and also n correspond to G. So that means we should really get an array of G and an array of H, right? So that means an array of G should be GS. And an array of H should be HS. So that should be the answer. So now if you reveal the answer, that should be GS followed by HS. All right, so that's the complete solution to this particular exercise over here, right? GS and HS. Yeah, that's correct. Yeah. So Majid, you were right. Good, very good. All right, so now I'll make a clean page for you with all the hints just today. So you can also follow that to do more exercise if you wish. If I were you, I would do the following 2 exercises, optional, but I think it'll be important for you, okay? Let me just suggest exercise for you, optional, all right? Exercises about this particular guy over here, right? Number 1, put this into eStudio to make sure everything compiles, okay? There might be some little implementation you will have to do for item over here for item, also for after, for fourth. I can quite easily do it. Correctness is not really what we're looking for over here. We just want something to really compile. So for example, over here, for the item, I'll just suggest something quickly. You can simply say the item would just be maybe you're going to return a tuple. You can just say result is really just assigned to, for example, it's going to be n and n, right? So you can simply say, I'm going to get a tuple. So it can be simply a tuple ms at position 1 followed by ns at position 1. Just for compilation, okay, just as some hints for you. Okay, number 1, put this into eStudio. Number 2, what you may want to try. What if, for example, I simply maybe swap the order of m and n over here. For example, swap the order of the generic parameter type declaration. Let's say item iteration cursor used to be n followed by n. What if I simply say n followed by n, for example? And now, what would be the fixes? And before you think about the fixes, I would suggest you do the following. As soon as you change from mn to nn, your iPhone Studio is going to send you some compilation error message, in which case I don't recommend you read it. What you should do is go back to this particular exercise over here to think about how it can work out what the fix should be. And then once you do the fix, and then recompile to make sure everything's okay. I would suggest try to find different spots in this particular example over here. Simply try to change them a little bit just to create some compilation error and see how you can fix them. So I think that one really tests you about your reasoning ability about how the generic parameters are being instantiated and used. That'll be my suggestion for some extra optional exercises for you if you wish to dive deeper. Okay, guys, any question about this particular exercise over here, right? So the reason I didn't really cover this as part of the lecture is for those of you who really want to try yourself first before you hear my answer, I think that'll be more beneficial, okay? But maybe many of you actually got the correct answer anyway without my guidance, and in which case I'm happy, right? If you haven't got the correct answer just by yourself, so now you would know the steps of solving this. So hopefully that will help you, okay? Any question before I finish this particular example? Okay.
Oh, I have a question.
Go ahead, please.
Hi, it's Pavel.
Hello, hi. Go ahead.
So I have a question. For example, if G and H have the same kind of same kind of type, for example, tuple of integer, integer. Then for 3.5.1,
yeah,
can we say tuple of MM or like NN?
yeah, Pavel is a very good question. So I think it's a good question here. Let me just sketch that a little bit without making any permanent changes here. So Pavel's question goes like this: the reason that we say this should be okay. So the reason that we say this should be H and G is because we got string and integer, but here we got integer and string, so they should be reverse the order. What Pavel was suggesting was, what if the question goes like this? If I only say string and string, and also this will also be string and string. In that case, maybe it would be okay if we also say G and H over here. I think you are correct if the question was given in this way. However, I would say in that case, if you're trying to work out exactly what a generic parameter should be, you should really try to treat this parameter here and this parameter here differently. Because in general, when you say G and H, you cannot assume they will always be instantiated by integer, integer, or string and string. You cannot assume that. So I think what I'm suggesting to you over here is way more general, because I'm just trying to show you G and H, they might just be instantiated differently, in which case you can really change the order so that you will have the right correspondence.
Professor, just
Thank
Okay,
just
no.
a continuation
Go ahead.
of
Yes.
Paolo's question. So, like if we just do integer and use the generics as we like, then wouldn't it be the violation of single choice principle? Because if I do something else, like for example string integer, I have to change it everywhere.
Exactly.
And not just at one
Yeah.
place.
So I think Parthiv, I think that's a good observation here. Remember, when I first talk about generic classes, the reason that we want to introduce generic parameter is because we want to really avoid code duplicates. So that's why you want to parameterize the type for any member. In this case, let's say keys and values, so to be G and H. So now let's say if you simply get rid of these two generic parameters, so that means here for the keys and values, you have to give some particular type over here. For example, string and integer. But now the problem is your database is very, very limited. You only got string and integer. But what if I want another database of account and BST, for example? In that case, you have to just duplicate all the code just to create account and BST. So you're right, that's going to violate single choice principle, right? Make sense to you? Okay, I hope.
Yes, Professor.
Okay, very good. Okay, guys, any more questions about this exercise here? I hope it's a good challenge for you. So I think, what's the main lesson? The main lesson goes like this. Later on, if you want to deal, if you have to deal with generic classes, not necessarily in the IFO context, maybe in Java, in any programming language that's going to support generic parameters, you cannot assume whatever order you see over here, you're just going to follow that order all along. For example, here, if you say G and H over here, it doesn't really mean this here must be G and H, not necessarily. So you have to do some reasoning over here in the worst case. Sometimes if you're lucky, simply guessing this should be G and H. You might be right sometimes, but sometimes you might be wrong. So that's why you want to be precise. Okay. All right. So since everybody's okay, but if you still got some struggle about this particular exercise, feel free to ask me to repeat this exercise tomorrow if you wish. Okay. Let's see this. Okay, Wei Ming was asking this question here. So when we talk about okay, so let's say this. Let me just the question is, over there we got something called tuple of H and G. Okay, Wei Ming was asking, is this a class? It's not a class. Think about it's more like a type. A type where the first element or first item is of type H, and the second element is of type G over here, assuming that H and G are in the context. So you should really think about this expression here is not declaring any new class. Instead, tuple is some library classes already in IFO base, in which case we are saying that the first item should be of type H, and the second item should be of type G. and we're just instantiating them to be H and G. That's what we're doing. Okay. I got another question here by Majid. Can I? No problem. Very briefly, from 3.3 to from 3. Oh, it's okay. 3.2 and 3.3. No problem. Let me just remind myself over here. So we got 3.2 over here, and also we got 3.3 over here. Okay, I got it. Okay, good. So now I'm thinking this way over here. So when we talk about 3.2 over here, you can think about it's like this. 3.2. You want to also think about this particular guy as well. Okay. I think it'll be easier if you think use this to really justify over here. If you look at this, you can see this is going to be a tuple of m and n. In that case, we know that this particular instantiation is really instantiating whatever g it is in this iteration cursor. So I think that might be an easy way for you to think about the g. Okay. Very brief, if that makes sense to you. Well, maybe you want to maybe reiterate what I exactly said from 3.2 to 3.3 in the video. Yes. Yeah, basically what I meant was when you, so if you go from 3.2 to 3.3, the main thing is you want to say that the iteration cursor over here is actually mn. And that one there really instantiates, really inherits from this particular iteration cursor. So somehow these generic parameter will be related in the way I explained in the lecture. Okay, maybe that's something we can take offline yeah, okay. All right, so guys, I think the recording should be quite complete. Maybe if you got any trouble, please rewatch the recording or maybe ask me to explain again tomorrow. I'm happy to do so. Okay. All right, let's move on quickly. Okay. Okay, so that's about the two things I actually have in my agenda. So now I can move on to the actual Google Doc. Okay. We got about, so this one take a long time, but I hope that really clarify many confusions, I hope. But if you really think that create confusion for you, again, study the example over here, and then maybe ask me to clarify again tomorrow. You know, I think that this exercise here is not trivial. It's actually quite challenging. I'm pretty sure you didn't do any exercise like this in your previous OOP course, so I think it's worth doing and worth understanding as well. Okay, so now I would suggest I may swap the order of the Google Doc question a little bit, given that we only got about 30 minutes or so left. So let me just switch a little bit. So one of the questions from the Google Doc is about explaining one of the quiz questions from quiz number 2 about using deep twin and also twin, etc. I would suggest I leave this question until tomorrow. So I can, because this one may just take another 10 minutes. You may want to hear maybe something that's more relevant to this week's lecture. So I will do this tomorrow, okay, I promise, okay? So let me go to this guy here. Okay, so this one just about how you can write contract in the design diagram. So that will be related to your lab number 2. So let me answer this quickly. So let's say this. For example, in your lab number 1, you got a tree node class, the tree node class. And let's say one of the precondition for some routine. For example, if you say, I forgot which one it is. Let's use a routine in general. Question.
For insert, maybe?
Insert, sure.
Yeah, I'm helping you. No, I mean, I'm helping you for the precondition.
Oh yeah, okay, good, very good. You're definitely more familiar with Lab 1 than I am. Good. Let's say insert, maybe left, maybe.
Yes.
Let's say, okay, now kind of rings the bell, I guess. P note, and also, you know what, guys? Let me make it even more interesting. Let's say it doesn't have to correspond to any of the routine you actually did in your lab 1. Let me just say a new routine. Let's just say R, because I don't want to give you any anything that's inconsistent with what you did previously. Okay. So now the main question really is about how you can display mathematics in the diagram. So I understand exactly what your concern is. Let's say we just have some routine in a tree node. Let's say your precondition looks like this. Require, okay? For example, let's say left is external, for example. Okay, that's the tag. Let me just move this a little bit down. Okay, so you can see the whole thing. Sorry, let me write it again. Otherwise, it's going to be a little bit messy here. Let's say we got a routine in the Trino class, and then we got a require, and then we say the left must be external. Programmatically, this is what you would write. You would say attached for example, left, attach left as, let's say L, let's say just L, okay? And then we can say implies. I think in this case, you can say implies. If the left is really there, in that case, that should be external. For example, implies L dot is external. Okay, so the question really is, let's say this is the precondition you have for the routine you want to show in the diagram. How would you show it? Because I'm pretty sure you're concerned about the statement I made in the diagram lecture. I said you should really try to display mathematics whenever possible. So now, in this case, how can you display mathematics? I would say very limited extent you can display mathematics. So how I would do it is like this, okay? First of all, you will have a class over here, right? So it's going to be tree nodes. And then you have some generic parameter, I believe, was it K or K and V, right? And then tree node is effective, so you would say plus over here, right? Let's say when you display this particular routine, and by the way, for lab number 2, remember this one page, I forgot the page number, but in one of the pages in the section for the diagram, it tells you exactly the features you have to include in your diagram. So we made it very straightforward for you, okay? So you can just refer to that particular list, okay? So let's say routine R is going to be included, right? How can you display it? First of all, you should definitely say require, okay? You may want to make it bold, okay? Make it bold. But you wouldn't get any mark deducted if you don't make it bold. That's fine, right? I'm just saying to make it look more professional. And then how can we display this particular contract? I would say every time you should really at least put a tag. So I would say that I will first of all put a tag left external, and then colon here. I would say just for this particular one over here, the only place I can make it slightly more mathematical is I can rather than say implies, I can use the implication symbol. So I can say over here attached left as L implies, right? That's the implication symbol. L dot is external. So this is definitely accurate. So this will be okay, right? That's version number 1. Okay, guys, that's version number 1. How about version number 2? Also, for the consideration of to make your diagram as simple as possible, I would say voice safety in this particular case can be a second concern because we're not really trying to compile a diagram, right? So I would say it will be okay if you write it this way. Right? Either way is fine. I'll let you choose. You can also say, so the tag remain the same, right? I'm just saying for this part here, you can write it slightly differently. You can say, simply say left dot is external. This will be okay as well. So I guess maybe many of you will actually prefer this way here, but it's much simpler. That's okay for the diagram. So now for clients reading your diagram, they can say that the implicit assumption over here must be that left must be attached. So I think that's okay. However, of course, if you put it into program, you have to make sure you still do the attached syntax. Whether to really put this level of detail to the diagram is up to you. I would say either put it this way or this way. They're both acceptable. Okay. Right, and then the second part of the question here is about how do you show current dot has key, has p key, for example, right? So I would say this one here, whenever you got any routine call, I would say if you simply put a routine call as in the diagram, that would be acceptable, right? So now let's say for this particular require, right? If this is what you wrote in the code, how do you show that in the diagram? I think it would be acceptable if you simply say current dot has p key. I think this will be okay. You're simply just calling some public query to make sure p key is actually over there. However, I have a better version for you. Okay, so that's version number 1. Version number 2, I'll put it here, is actually better. Given that we're considering your database as a relation, and then p key over here, if p key is an existing key, that means it should be a valid domain value, right? So why don't we put it like this? Why don't we say number 2 in the diagram? You can say p key over here is a member of the domain of the model. And remember, your model over here is simply a relation, right? And for relation, you can definitely check its domain. And the domain is of type set. And now you're saying that p key is simply a member of that particular set. So I think number 2 is actually better. All right? Guys, that makes sense to you about these 2 examples, I hope. Okay? Whoever actually put that Google Doc question, I think it's a good question, right? All right. Okay. So let me, if there's no follow-up question to this, let me move on. Okay. Okay, so this guy here, this question here is about deferred versus effective classes. Okay, so I just put a slide here because just the context. Okay, I don't need to go over the definition for you. You got a slides. Let me just read the question together with you. What is the purpose of using deferred class as a static type? Okay, and then let me answer the first part. Okay. So now, let's say this. Whenever you have a deferred class, let's say A over here, if you say deferred, okay? A deferred class usually wouldn't just exist by itself, okay? A deferred class won't exist by itself, because if a deferred class never is only just exists by itself, that means you can never use it as a dynamic type. So that means over here, if you try to write something like this, right? List, which is deferred as the dynamic type, is not going to compile. That's something we know very well, right? So now you can assume that every time if you have a deferred class A, for sure there will be at least one effective descendants over there, for example, B, that's going to be effective. So whatever that's deferred, for example, F1 in A may be deferred. In that case, F1 in B will be effective. So at least you're trying to make every routine in the class A over here effective, right? So we can also got maybe more over here. You say C over here and also effective. So the advantage of declaring a variable, let's say if you say objects over here of type, think about this. If you say object of type A, let's say that's design decision number 1. Design decision number 2. If you say object is of type B, okay? Think about design decision number 1 versus design decision number 2. Which one will be considered as better? Okay? I would say here the way we judge this is by saying how flexible you are by allowing the static type over here, right? So now thinking this way. If you say object over here, let me say here, object, so now. So when you say creates, you're gonna pass on dynamic type over here, and then objects dot make, for example. Assuming that make really exists as a constructor. So now, what can we put inside this particular dynamic type over here? In design decision number 1, you can choose both either B or C, right? Because B and C, they are the descendant classes of A. On the other hand, if you try design decision number 2, for example, design decision number 2, in that case, if the static type is simply just B, so that means your only option would be just B. So you got one fewer option here. So now you can see design decision number 1 can give you more options for the dynamic type. So that means potentially you got more option for you to choose for implementation. So that's why it's called a program from the interface, but not from the implementation. So you want to choose the type for the static type to be as general as possible. Okay. later on, after the reading week, we'll start reviewing about inheritance very thoroughly. So that's something I'll discuss further about what you really should choose for the static type. Okay. Okay, and then let me just go on with the second part of the question, and then I can see there may be some chat going on. I should really check. Okay. Okay. So can the so now let me just be picky here. The static defer feature. So there's no static over here. So I don't think that's what you meant. You're saying the feature, the defer feature in the static type. I think that's what you meant. Can you call that in the defer class? The answer is yes, you can call that. For example, let me just give you another one. And this is related to the lab number 2. For those of you who haven't got a chance to see the Q&A from last Thursday about lab 2, I think there's one section there you really want to follow through in order to get better understanding about lab number 2. Let me just point that to you, and I'll explain that quickly again. If you go to the lectures page and go to lab number 2, okay, if you go there, and then I want you to look at over here, here. You want to look at this particular part about visualizing the model and database implementation. So that's something you would like to look at, this part over here. Okay, this part. Don't miss out that part. I think that part is really important for understanding about your lab number 2. Okay, I'll leave that to you. And then let me go back to the iPad, okay, very quickly. So now, let's say this. Let's say we got different classes over here. Again, let me say I got class A over here, that's deferred. And we got inheritance over here, and we got inheritance over here. B and also C. Let's say we got features over here. Let's say F1, maybe some routine. Let's say F1 is simply just deferred, no implementation. Okay, so that means for B and C, they will be forced to provide some implementation. So I would say F1 over here, but it's a plus. And F1 over here, there's a plus. Of course, later on, if you got another inheritance over here, you might choose to say F1 plus plus is really fine. But let's not worry about the complexity here. Okay, let me just get rid of it. Okay, so now over here, let me say this. If I got objects of type A, okay, and then let's say we do some object creation in the middle. So now, can I say obj.f1? Can we do that? Even though f1 is deferred, can we do that? Will this line be problematic or not? Is this okay or not? The dot 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 over here, I'm assuming that object has been initialized correctly. Okay, Majid, somehow you said a compilation error. I think you have been successfully misled by me. That's intentional, okay? So let me say this, okay? So it turns out this is actually okay because, again, this will be something I would like to review thoroughly with you, maybe after the reading week. So I wouldn't say too much. It will take too much time today. So let me say briefly. Over here, what could have happened is, of course, in order to really instantiate OBJ, we have to say creates over here, and then we got to put some dynamic type over here, and then we say obj.make. Okay, so now when compiler sees that you say obj.f1, what the compiler will do is it's going to look at what's the static type for obj, which is A. Does A declare some feature either effective or deferred? Yes. F1 is actually declared over there, so this is okay. So that's how the compiler judges in the yellow highlight. Okay, and then dynamic type is really about what you put over here. So let me use a different color here. Dynamic type is somewhere in the middle. You should have at least initialized the obj at least once. If you didn't do it, compiler is going to complain that you might have like a object called on the void target, right? So now what can we put over here? Right? Again, program from the interface. So now it can be either B or C. For example, if we choose B over here, so that means it's guaranteed we got at least one version of F1 that can be called at the runtime, because whatever effective descendants that inherit from whatever effective descendant that inherit from A will guarantee to implement F1, right? Any effective, like a plus and plus over here. So now, when we call obj.f1, so which version will be called? First of all, how many versions are available? How many versions are available for us to call on F1? There are 2 versions, right? 2. So it can either be from B or it can be from C. That's point number 1. Okay? And point number 2. In this particular scenario, let's say the last creation we did was to create obj to be dynamically of type B. So in that case, we know that he's going to call the F1 from version B over here, right? So it's going to be version B. Version of F1 from B will be called. Okay, so this is something we assume you actually learned from the previous OOP course, specifically 2030. But I know that for many of you, it might be a long time ago, maybe almost a year ago. That's okay. I think for this class, for this course, let me give you a little bit preview of what's going to happen after the reading week. After the reading week, we'll talk about a number of design patterns, like iterator, just one that we talked about before the reading week. And then we're going to talk about basically composite, visitor, state, observer, etc. So these are the common design patterns that will exploit or leverage the polymorphism and dynamic binding for inheritance. So that's why we have to review the subjects. That's something I will make sure you got proper review. Okay? But if you don't think you're following what I'm trying to say over here, that means you may have forgotten about what you learned from 2030. So you may want to do a little bit of catch up yourself before I talk about this stuff. Okay? Okay, so I believe I answered the question over here already. So definitely you can call the deferred feature because it's guaranteed there will be some dynamic type from the effective descendants classes that you can call. In which case you just have to determine which version it is. So according to dynamic binding, it's going to whichever version that's going to be called depends on the dynamic type. In this case, B. So you're going to call this version specifically. All right. Okay, so that's about this question here. Okay, we got another one here. This one's easy. Okay, this one here is really about, I think that's one of the example I did in the diagram. So database over here, what I said over there was every declaration of a variable should really indicate a client-supplier relation. So that means, in this case, you can definitely do, let's say I show you the compact view. So I would say database. Let's say that's effective, okay? And then we also, let's say we got string and string. Let's say I want to show both if I want to. You can definitely put the string. And typically, for any class that's part of the base library, like a library class, you don't have to show in compact view unless really necessary, unless, okay? Okay, so now we got a client-supplier relation over here. So now you got NN and N. So you can definitely say NN and N. Okay, that's what we said in the lecture. So the question goes like this. Apparently, it is allowed if we simply put maybe N over here. Let me just use a different color so I can show you the difference. Let's say I use red. Let's say if I simply rename, okay, NN and N, okay? If I simply rename this particular parameter to be simply N, so now you can see this one here and this one here, they are of the same type. In that case, of course, you can simply just use N over here. That will be okay. What's going to be interesting will be another case, okay? Let me just use another color, okay? Let me use maybe orange, okay? Here, N and also N over here, they're of the same type, simply just string. What's going to be interesting will be, what if I say N and N, and also, let's say rather than string, I simply put name. Basically, you now got two suppliers of the same name, N and N. However, their types are simply just different. How would you show them? That's another example, right? So now how would you show it? Let's do very quickly. So what you have to do is you're going to say database. So database over here plus, okay, and then we got basically either name. Let's assuming that name is a class, right? And also string. So again, you can put name over here. Let's say that's effective. And also you got your string class over here. So now apparently you should really draw these two client-supply relations separately. They should not point to the same class. So this will be another one over here, right? So one would be, this one would be just be n. This one will be n as well. Okay, so I'm just showing you different possibilities over here. Okay, guys, are we okay with this? This question is just really about what if you got this supplier name of the same name. That's okay, as long as you know how to show them. So that'll be fine. Okay. Okay, let me go on to the next one here. Okay, we got about 15 minutes left. So I think maybe at least we should really try to handle this one here. I think you guys asked very good question to me, on the Google Doc. Okay, let me try to show to you. I'm not sure if I can maybe leave maybe 5 minutes. You can ask me some question about Lab 2. We'll see. If not, you can still drop by my office hour tomorrow or appointments. Okay, let's see this. Hopefully you remember this particular example over here. If you don't, let me remind you very quickly where you can find it. I would say this example here is really fundamental. Okay, if you go to over here about the basically there's about 4 lecture. Oh, actually it's not a slide. It's actually just the iPad exercise, right? If you go to this particular our iPad notes, let me just show you quickly. Should be fit to the page. Okay, so now if you go all the way to, oh, sorry about that. Okay, so if you go to after the diagram, I think that's the exercise we did together, right? So that's the part 2, asserting set equality, right? So we started with this particular post condition here, and then we say that if the original post condition is simply just this, would that be enough, right? And then we talk about how you can assert the complete post condition. And then you guys actually got a very good question here about why I have to use implies over here rather than and. Similarly, why am I using and over here rather than implies? That's a good question here. Apparently, if you change from implies to and, their semantics or their meaning will change as well. Their meaning wouldn't be the same for sure, because implies and and, they mean something different. Similarly, if I change from and to implies, they also mean something very different. So you want to know which one to choose. So here, I think there's a very good example here. You can see I choose this one here to be implies rather than and. I choose and rather than implies for good reason. I didn't really mention that in the lecture. I was expecting you guys to ask me, but that's good. Put it on the Google Doc. Okay, so that's about the context for this particular question here on the Google Doc, right? Let me go back to this particular iPad notes over here. Let me just drag this away. Okay. Okay, so let me talk about the first one here. Okay, let me just remind you very quickly. Let's talk about this guy over here, right? This guy here. Remember what the original post conditions say. Basically, for that one, they want to say all the positive number in A, which is the input, should also be in the result, right? So what we are saying is across A is X. So we know that X is going to be of type integer over here, right? So now we are saying that every X, if X is larger than 0, that means result the return array. Let me just give you one example quickly, right? Shall we? If I say all positive value over here, right? If I simply just give this to you, let's say maybe 2 minus 1 and 3 minus 2. We know that the correct result should be 2 and also 3, right? So what this guy here is really saying, go across A, which is this particular array, right? And then if every member we're going to look at will be X. X can be 2, can be minus 1, can be 3, and etc., right? So now, if X is larger than 0, that implies result in this guy here must contain that particular element, okay? For those of you who might be following what I'm saying here, hopefully you realize what's going to be the consequence if I simply change from implies into and. If you haven't seen that, let's do it together, okay? So now, the first point I want to illustrate is, for this particular green one, you can only use implication. You cannot use conjunction. Okay, let me say hypothetically, if I change this one here, rather than implies, it's going to be conjunction. I'll pause a little bit. Would that be okay or not? If you don't think that's okay, can you give me one scenario where something wrong is going to happen? Anybody?
In end, right, Professor?
Yes. Yeah. Let's say I have. Yeah.
Yeah. So
Yeah. Go ahead.
yeah.
Please.
So when you go to -1 after 2, which is after 2, yeah, the second element.
Yeah.
So it is not greater than 0, right?
Aha. And then?
Yeah. So
Carry on.
and it also does not have a result. So it would be false. I mean, anyways, false and something is false. So it will return false, and everything will be false because it's all right.
Okay.
So everything will be false.
Sure. Everything will be false. And then what's the consequence?
Yeah. But I mean, it is also not in result. So it should be false. So what I mean to say is it is negative and it is also not in result. So this means that this condition should be true, right? I mean, we don't want negative numbers in result.
Yep.
So it should be implies.
Okay,
Otherwise,
good.
everything will become false.
Yeah,
The post condition will be violated.
So now let me, yeah, exactly. So be post condition violation. Exactly. So guys, let me summarize exactly what Parthiv is trying to say here. If I, think about semantically what this really means. If you use implication over here, you're saying that every number in the input array here, number one, it should be positive. Number two, whatever it is, it should be in the result. So you're saying that my input can only look like, for example, 2, 3, and 4, for example. There should be no negative value in the input array. That'll be too restrictive on any potential client who's going to use this routine. You're saying that if you contain minus number here, it's not allowed. Then what's the point of using this over here? Then in that case, you can just return the entire input array always. That's not the point, right? So now, just let me summarize what Pareth just said. If I simply got implication over here, when I'm looking at -1, for example, -1 larger than 0 is going to be false. So now for conjunction, you got one side to be false already. So for this particular iteration is going to be false. And since we talk about universal quantification, so the entire thing is also going to be false. And now we're talking about in the context of post condition. So what you will get is post condition violation. Okay, so that's not good. So guys, this is the explanation about why, in this particular case, we should really use implies rather than conjunction. Because if you use conjunction, the meaning is simply too demanding. You're demanding that any input array should always contain a positive number only. That's not the intention for this particular routine. Guys, make sense? I hope. Okay. Okay, so if I have no feedback over here, yeah, exactly. Ovek, that's you're just rephrasing what I said. That's very good. Okay, so now let's talk about the second one, the pink one over here, right? So guys, I think that's really interesting bit about this course, because since now we are trying to check something at the runtime, but on the other hand, the only way for you to figure out whether something's going to happen like a violation, you have to have some logical mind to really justify. So I think it's good exercise for you. Okay, so now this guy here, right? So now we understand that this must be implies, right? Because now if you say implies, by the way, if you say implies over here, when you get -1 over here, so that means if for the implies, if you got the antecedent being false, the entire implication would just be true. So you bypass that case already. So that's how we use implies. What about the pink one over here? I said that before that this guy here must be and conjunction. So now let's say hypothetically. Let me use a different color here. Hypothetically, let's say I'm going to change this from conjunction into implication. Okay, since you guys kind of follow through the way you should really prove that something is inappropriate. Every time, let's say for the exam or for some future quizzes, or maybe the current quiz, I don't know which one, right? Every time if I ask you to justify something, for example, I might simply ask you why using conjunction over here is inappropriate. You should always give me the so-called witness. For example, the witness in this case would be this particular array, which is going to cause some post-condition violation, which is unexpected. That's why conjunction should not be used, all right? So now here's my question for you, right? So now, can anybody suggest a witness that will suggest that if I use implies rather than conjunction, something wrong is going to happen at the runtime. Anybody?
Can I go again?
Please, good. Go ahead. Yes.
Yeah. So it will give you wrong results because if there is a -1, so -1 is not greater than 0, and false implies something becomes true.
Okay. Okay. That's very good. Very good. Okay. I think you're kind of jumping many steps over here, but I understand exactly what you meant. That's correct. Okay. So guys, let me set you the context. Okay. Just for everybody's benefits. Okay. So what Parth said is exactly right. So think about the following scenario. Good. Let's say this. If we got all positive values over here, okay? So now let's give the same example. Let's say 2, -1, 3, and -2, okay? 2, -1, 3, and also -2, for example, right? Let's say here. Let me say this guy here, and then let's say this is the input, okay? Let me ask you this. What if the output, remember we said before, you cannot assume that your post conditions, your implementation is always correct. And I can see Majid actually already suggested something over here, right? Very good. What if I got, let's say I got 2 and 3 over here. Let's say I always got something wrong. And -1 over here. So what's going to happen here, just for this particular guy? Apparently, you can see that's wrong because this guy here contains some minus number over here. So that means when you check this particular guy here, let's say, I think for the first and second iteration, you'll be okay because 2 and 3, they're simply just positive. And then A does have it, so that's okay. So now, what about -1 over here? For -1, let's say for the third iteration, okay? For the third iteration. So we got x larger than 0 implies A dot has. Sorry, let me write it better. Implies A dot has, and then we say x over here. So now what we're having over here is we got -1. So -1 larger than 0 is simply just false. And over here, A dot has, we know that it's actually true, right? Because A does have -1. It doesn't really matter. So whatever this is, the whole thing is going to be true anyway. So that means we're not going to get any post-condition violation, even though the output is wrong. So you can see it's kind of the opposite behavior of the other one. But so now what's going to happen is no post-condition violation. Even though, although the output is wrong. Specifically, you can see that over here, we got -1 over here. That should not be included. But as far as this particular post condition is concerned, it's going to give you true. All right? So guys, any question about this? I hope you're okay, right? Okay, I think that there's some follow-up question to this. I will maybe cover that tomorrow. I will continue from the rest for the rest tomorrow. But I can potentially stay for 5 minutes more. Do you guys have any question for me in general about Lab 2? I can try to address them if you wish. Guys, any question about Lab 2? Shafan, you say yeah. Okay, go ahead. Yeah, ask me the question. I can stay for 5 more minutes. Anything. Go ahead. Shafan, you want to go first? Shafan, you can feel free to speak up if you wish. That might be easier for you to, rather than typing.
Okay, so any key that's that exists in the database, can we assume that has a non-void value?
Yes, you can assume that. So Shafan's question was, for the database, let's say if a key exists, does that key's corresponding value should be non-void? Yes, you can assume that. Yes.
Okay, thank you.
No problem.
I have a question.
Nora, go ahead.
Yeah, since we are using relation instead of function.
Yes.
Do you mean that we can have two keys, like having one key having two values?
No, that's not what we meant. Good question. I think that's something I kind of mentioned that in the lecture series number 4. Okay, but I'll explain that. Okay. You know what? Let me also refer you to one of the part of the instruction there, but I'll explain to you anyway. I just want to show to you. So if you go to the instruction for, okay, just bear with me. Just give me a few seconds, a few moments here. I want to show you where you can find it in the instruction. So lab number 2, instruction, and then PDF. Okay, good. So that's your instruction for lab number 2. So I think, Nora, you can find the answer, part of the answer over here, and then I'll explain further. If you go under section 6, and then I think design decision over here, right? You can see over here, you can read a very short section there. You can read it again. But that one there is really about, even though the function, the model type is actually relation, but the way the relation behaves is really like a function. Okay, so let me explain to you what I meant. Okay, so let me go back to my iPad over here. Okay, let me just bring it back. So we talk about the model relation for your lab number 2. Okay. So model is basically a relation over here. And then let's say, let me just make it more concrete. Let's say we got string, and also we got integer. Okay, let's say. So apparently you're thinking that, for example, let's say if this is your model, let's say you got domain. Also you got range. You are basically asking, can we have something like this? Let's say Alan and also Mark. Let's say for integer, for the range, let's say we got 1 and also 2 and then 3. You were asking, can we have this scenario where maybe Alan is actually pointing to maybe both 1 and 2, right? First of all, this will be considered as a valid relation, right? But it's not a valid function. Because the very definition for function is every domain value can be mapped to at most 1 range value, but in this case you're mapping to 2. So this is not a valid function. So this is the scenario you can assume it's not going to happen for your lab number 2. So you can think about, even though your model is actually a relation, but effectively it behaves like a function. Okay, so what will be the consequence of this? The consequence is like this. So let me just show you this. Okay, so we know that this one here is actually, you can assume that it's not going to happen. Okay, let's say the actual relation we have is, let's say Alan is mapped to 1 and also Mark is mapped to 3. So this will be a valid function. Okay, so now if I say this, if I say model over here, and I think one of the very important operation for relation will be the image operation. If you say model.image over here, I think I also explained this in the lecture, but you can also review that part. If I say here Alan over here, and you can also say this, they are equivalents. You can also say model almost like a function application, almost like, but not exactly the same. You can also say Alan over here. So this notation is also allowed. So both notation will compile. So now let me ask you this. Let me write it again. Okay. If I say model, which is a relation, I want to get an image of Alan. And now if I say tilde over here, I simply say 1. I can tell you that, first of all, this is going to compile. Compilation is not an issue, because this one here is simply just going to, tilde is just going to compare these two objects anyway. However, are we really comparing apple to apple? That's the question. Are we or are we not? Nora, you want to help us out?
I don't understand what do you mean exactly.
Okay, sure, no problem. So now, first of all, we know that model, using this square bracket notation, we are really calling model.image. Are you okay with this part?
Yeah.
Very good. Okay. So now, model.image, Alan is going to return something. And we're comparing that something against a single value? Are we really comparing apple to apple?
Are you saying in the case that the 2 is not there, like there is no link between Alan and 2?
Let's say just for this particular case, let's say Alan is really pointing to 1. Let's say that's really the case. But do you really think this comparison really makes sense? That's my question. To answer that, you may want to know what image really means. Okay, so let me just show you very quickly to, I don't want to take too long for you. I know it's already about 7. Everybody want to have supper. So why don't we just go very quickly to, okay, if I go to relation here, and then you can see the image, okay. You can see that the return type for image is simply just a set, right? So now, theoretically speaking, every relational image is going to give back to you a set rather than a single value, unlike a functional application. If you go to, for example, the function class over there, go to fun, and then you simply just go to item over there, okay? And just go there quickly to show you. And currently, it's not really referenced, so that's why you don't see the feature over here, okay? But I'll just go there quickly to show you. Maybe I can simply just look for that particular symbol over there. You know what? Let me just show you this properly. So let me just go to the root. Yeah, guys, I will try to finish within a few minutes. Bear with me. I'm glad everybody's still staying. Thank you. But I'll finish that soon. Let's say we got a function from string to integer. Okay, let me just do that quickly. And then if I now go to the function class, you can see we got many features over here, right? If I simply go to item, that's where I want to go. So now, Nora, notice the difference here. So if you use a function application using a square brackets, it's going to return a single value, just a range value. On the other hand, if you go to the relation class, again, if you go to the relation, and then you go to the item over here, that one there is really like a relational image. That one there, you can also use a square notation, square bracket notation, but that one is going to give you a set, right? So now, so that's why over here, if you think about it, so now that's why over here, when you actually consider this particular expression over here, this is really a set of integer. And this is really just a single integer. So you're really comparing set of integer against an integer over here. So that's not a way to compare them. So you will just get false anyway. Okay. So now the question will be, what will be the correct way to really make a right assertion? Okay, I write it down for you. That's also mentioned in the lecture. Okay. So the correct way of doing this would be, you want to say this. So model the relational image of Alan on the model, first of all, .count is equal to 1. You're saying that it's going to be a set, but it's going to contain only a single element in the set. It's a singleton set, basically, right? And number 2, I can say and. Over here, you can say model Alan dot has 1. Okay, so these two are the way to really make sure the relational image that you are returning back is only a single value over there, just a single one. You're just gonna be type correct over here. You cannot just compare a set directly against a single value. You cannot do that. So Nora, does it make sense to you?
Yeah, it does. It does.
Okay,
yeah, you said all that in the lecture. I'm sorry.
Okay, no problem. That's fine. So maybe later on when you reach that part of the lecture, just to make sure you pay attention to it. That'll be fine. Okay. All right, guys. Thank you for staying. So I still have quite a bit of question there from the Google Doc, but I would say if you haven't really attempted your quiz yet, still attend tomorrow if you can, and then I'll finish that tomorrow. And then I think yeah. And then if you got any more questions, just bring them tomorrow. Hopefully tomorrow I can leave more gap for you to let you ask about the lab 2. Okay. Where can you find the notation for subtracted by, etc.? Okay. So now how can you find them? So if you go to the relation clause, for example, I think you cannot just say subtracted by. Oh, actually, you can. If you remember, you can use the wildcard expression, subtract, for example. So you can see these are all the features that are related to subtract. So Jiahao, I think that maybe that's what you're asking. For example, if I go to range subtract by, okay, that one may not be a good example here. So let me just do another one. I think for some query over there, as I mentioned in the lecture, you can also use their symbol. So now let me just go to what about domain subtracted by? Okay, good. So now you can see there, you can either say relation dot domain subtracted by, pass a single value. That's one way to go. And that one there is going to give you a relation like current, right? Another way to do it would be, you can simply say, there's a symbol over here. So you can simply say the infix operator. Okay, now let me write it down very quickly, right? I really want to let you go. So this one, let me write it down on my iPad first, and then I'll show it to you. So relation at, okay. So what I can do is, you got a relation here, and then you can simply put the infix symbol that you saw in the iPhone Studio, and then you can say maybe some element, some domain value. I can say D1, for example. So this is also a valid syntax to write if you prefer. But you cannot lose anything if you simply just say domain subtracted by, like a normal routine call. That's fine too. All right. All right, guys. Thank you so much for coming again. So I will see you tomorrow. And then if you got more questions, please bring them tomorrow, or you can update the Google Doc. Either way. Okay. All right. I'll see you tomorrow. Have a good night.